folks. Welcome to our session. Actually, this should be session number 5 of our Alchemy in the Lab. And today we got a good topic as the registrations are showing. We're going to be talking about a little bit of AI coupled with some identity with our friends from Okta. And we're going to be talking about shadow AI and how you can mitigate it before it becomes an exposure risk. We got a good panel today, and always fun when I have my friend Pascal on. We're going to be joined by Jonathan as well. So we're going to give a quick intro. So if for those who don't know me, my name is Pete Downing. I host the Alchemy in the Labs as well as a couple other webinars we're running. And for any questions or follow-ups, please don't hesitate to reach out post-webinar, and I can always connect you with the right people. Also on today's webinar, we got Pascal. Pascal, if you can just give yourself a quick intro and tell us, where you're based and how long you've been at Alchemy and what you do for Alchemy.
Yeah, sure. Thanks, Pete. My name is Pascal Pierre-Louis, and I'm a principal architect. And I lead our overall identity security practice here at Alchemy. I am based down in South Florida, but I cover I support our organization nationwide. So yeah, I do all things identity security. And if I could summarize what I do real quickly, what I primarily focus on is helping customers map identity security product capabilities to their use case and business requirements. Looking forward to our session today.
Thanks for jumping in. I know you're a busy man. So, also on the call, we have an old time friend of mine, Jonathan. Jonathan, give yourself a quick intro. Where you based and how long you've been with Okta, and what do you do for Okta?
Yeah, absolutely. So, hi everyone. My name's John Campos. I'm based in South Florida, and I've been with Okta for about 5 years, and I'm a principal forward deploy engineer supporting our AI agent efforts. Securing agents all day, pretty much here, Pete.
Awesome. Yeah. Man, I'm the only one not in South Florida, I think, or well, along with a couple other folks in the background. So shout out to April, Jason, and Robert. But hey, I'm in good old Charlotte, North Carolina, so I'm almost in Florida. But before we dive in, I always like to do this, and I've been doing this lately, and I just want you guys to think about all the AI you have in your environment today, and then all the potential AI agents you could have out there today. And think about this as your next identity tier. And is anything governing them? And as we saw from the survey, I think a lot of the answer is going to be no. And so you could argue they're already operating outside of it. So how are we going to solve that? And that's the goal of today's session is we're going to show you ways you could potentially get some wrappers around these agents, unknown agents, or even known around that today. So with that, I'm going to hand over to Pascal. And Pascal, I'm going to stop sharing so you can share your screen. And you're going to take us through kind of what you're seeing day in and day out as an identity expert and give us kind of I like to say, state of the union in tee up Okta and how they're gonna solve it.
All right, sounds good. Well, first, can you see my screen? Is that visible?
Yep, we're all set. I can see it.
Perfect. All right. Well, as Pete mentioned, we're going to spend the next few minutes exploring some key considerations surrounding AI and identity security that you should, take into account as you plan to strategize around what it would look like to secure AI and the identities tied to these agents that you're building. And based on the polls, and as many of you are likely witnessing in your organization, what we're seeing is that AI agents are multiplying fast across platforms like Microsoft Copilot, AWS Bedrock, Salesforce Agentforce, Vertex, and even custom AI agents that are being built. And ultimately, this is creating a growing population of non-human identities in the environment. And what we found is that most organizations do not have a single pane of glass for these identities. So service accounts, API keys, OAuth tokens end up scattered across cloud environments without a centralized inventory or lifecycle management governing these identities. And oftentimes ownership is unclear on these identities, which means that many agents do not have named individual humans accountable for their access or the behavior that these agents are performing. And that lack of ownership creates monitoring gaps. So when behavior changes or access expands, no one is consistently watching when this is happening. And privilege creep happens much faster with these agents because they bypass normal human review cycles, or so essentially overprivileged tokens persist, and when we see that happening, that that identity security blast radius increases over time. Now, the overall takeaway here is that AI agents are now acting like identities in our environment, but without the visibility, ownership, and governance controls we typically expect for human identities or human users. So as I previously mentioned, AI agents exist across different platforms: Microsoft, AWS, Salesforce, Google, and several other environments, including custom and in-house environments. What that means is that security teams are not managing a single identity type. They're essentially managing many different identity types across different platforms, which creates fragmentation. And each platform also introduces its own credential patterns, adding another layer of complexity on top of that fragmentation. So now, in our opinion, the highest risk area is typically custom or in-house built agents because they often rely on long-lived API keys, static secrets in code or configuration, shared service accounts with limited ownership tracking around these identity types. Now, the key point here is that AI identity risk is distributed, it's not centralized, and identity governance has to account for both platform-specific identities and also the custom layer at the same time. Now, what we're trying to convey here is the main takeaway is that AI agent identities are already widespread because we're already starting the process of adopting these use cases because that's what the business is looking for. And the highest risk identities are often the custom ones we build ourselves and never actually govern. Now, as I mentioned before, that the biggest and most immediate risk is going to be your static or any long-lived secrets, especially things like API keys embedded in code or configurations that essentially persist indefinitely and can grant access and in many cases privilege access without expiration. Now, the recommended approach there is to consider vaulting these secrets and enforcing things like rotation SLAs or just overall rotation and blocking the use of static secrets within your CI/CD pipelines. Token hijacking is another critical risk to consider because stolen agent tokens can let attackers impersonate AI systems and trigger downstream actions accordingly. Now, the recommended control there is to leverage short-lived tokens, leverage things like network or IP restrictions, and even SIM alerting, so that whenever you have suspicious tokens being reused, you're alerted accordingly. Now, continuing down this list here, orphaned agent identities creates a serious lifecycle risk, especially when projects end or teams change, but the credentials remain active without an owner, right? Now, the mitigation there is ownership, right? Ownership and automated cleanup. Require an owner at the point of provisioning. Automate deprovisioning and alert on extended inactivity, such as 90 days of inactivity. Now, excessive privilege is also a high severity risk because agents often get fairly broad roles like owner or high-level admin rights just so that we can make the deployment easier and essentially faster. Now, the answer there is to enforce the concept of least privilege by default. We also consider that for both human identities, but especially so for non-human identities. Also implementing controls like just-in-time elevation and reoccurring access certification reviews for these non-human identities. And lastly, cross-platform identities for all is still important, even though it's ranked lower, essentially, because a single agent may have identities across your different platforms, Azure, AWS, without any team seeing the full footprint of what that identity has access to. That requires centralized inventory and cross-cloud discovery to correlate identities across these various platforms that we're leveraging these agents within. Now, the main takeaway here is that AI agent risk is manageable, but only if we treat it like an identity problem with clear priorities and operational control wrapped around that. So now the problem that we're seeing, the problem essentially that we're seeing today is that AI agents are usually created by developers, not IAM teams. So it's outside of the control of the identity teams and their governance processes that they typically would have for the human identities. Now, most cloud identity environments do not provide a standard owner field, if you will, and which makes accountability inconsistent from the beginning. Agent credentials often outlive the projects that created them, so access persists even after the business context is no longer there. And org changes make the problem worse because restructuring can leave identities orphaned, and access reviews typically skip non-human identities entirely. So we recommend considering a full role ownership model to help solve that gap with clear accountability. So the technical owner would be the engineering team or the builder responsible for the credential hygiene, rotation, and privilege review. The business owner is accountable for what the agent is allowed to access on behalf of the organization. And the IAM custodian is, they're responsible for enforcing lifecycle controls, policy compliance, and the overall access review orchestration. And finally, the risk approver is a security function that approves privileged agents and receives alerts on anomalous behavior. Now, the main takeaway here is that non-human identities, they can become governed only when ownership is explicit, shared across the right roles, and tied to both technical and business accountability. So now that we've outlined the challenges, of essentially managing identities for AI agents, let's review a high-level implementation roadmap so that we can start the process of reducing our overall risk. So now phase one of this roadmap here focuses on visibility, performing a form of agentless discovery across the cloud tenants, right, where we're looking to enumerate service accounts, manage identities, API keys, and establish a baseline inventory. The goal of phase one is to identify existing non-human accounts, so non-human identities, and tag them so that we can they can be measured and effectively measured across our program. Measured and managed across our program. Sorry. Phase two is about accountability and context, right? We want every non-human identity to get mapped to both a technical and business owner. This is also where classification and risk scoring begin, using factors like privilege, exposure, age, and whether the identity is an AI agent versus a traditional service account. Now, phase three turns these new insights into action. So high risk and stale credentials are rotated or revoked, just-in-time access is introduced, and quarterly access reviews are launched. Detection also becomes operational in phase three, with non-human identities or non-human identity events flowing into your SIM and SOAR processes. And phase four is the steady state, right? Provisioning becomes automated through IGA, workflows, policies are enforced consistently, and the AI agent identity is embedded into our onboarding and overall governance processes. And the overall target end state that we're after here is continuous posture management. With continuous posture management, we're introducing things like monthly reporting on the CISO's dashboard so that this effectively becomes more of an ongoing program rather than just a one-time project. And the main takeaway with this here is that this is not a rip and replace effort. It's essentially a staged program that starts with the concept of inventory and centralization. Then we layer on ownership and risk. And essentially, this was going to mature into a continuous governance model. So now that we've discussed a roadmap for adding continuous posture management to your overall identity security program, let's review some high-level next steps to consider going forward. So step one, again, to reiterate, is to run non-human identity discovery sprints with the goal of enumerating and centralizing machine identities across cloud and on-prem environments within the 30-day or so, period, right? Step two is to define your AI identity security standards, and this is an important one. We want to include things like enforcing ownership attribution, setting a ban on the use of static credentials or standing credentials, setting mandatory time to live for these types of identities at the time they're provisioned. And step three, which sort of this segues into step three, which is really to start the process of piloting just-in-time access for these agents. So starting with a high-risk workload and replacing whatever standing credentials that are being used with a form of ephemeral access, because that's ultimately what we want to see from a policy perspective. And step four is going to be to integrate these non-human identities into your identity governance processes so that AI agents, service accounts are now included in your access review certification campaigns. Now, the main and final takeaway here is that we do not need to solve everything at once. We need to start with discovery, right? We need to set standards early, and we want to pilot strong controls and then fold AI identities into our existing governance models. That's all I've got. So with that, I'll hand it over to you, Jonathan, so you can showcase the Okta for AI agent solution.
Absolutely, Pascal. And look, really great content here. I think what we want to do here is just kind of really get a hold of all of these AI agents as we're absolutely building them completely end to end. And everything that you mentioned is exactly the maturity model that customers really need to follow, which is just discovering these agents, having a way of actually provisioning them and registering them, and having a way of governing them. And what I'm here to do today is, you really set the stage very well in helping customers understand how we really have to do these things. And I really want to highlight specifically how we do these things and why we do these things from the perspective of really just securing your agents overall. And, I think quite frankly, we say a lot, this is an identity problem. Why is it an identity problem? Because, quite frankly, what we want to do is build policy around an object. We have users today that we build policy around. We have groups today that we build policy decisions around. And then, of course, on the resource itself, we enforce that policy so you don't have access to certain things on a given resource, like Slack or Salesforce. Why does an agent change that? Why is an agent now absolutely completely reinventing the wheel of policy decision and policy enforcement? And I think that's the key component to really recognize here, because the number one thing to recognize is your agents are acting on your behalf to your resources. Today, we wake up and we say, hey, Claude, check my email, follow up with all of my customers on Salesforce, and then go ahead and summarize a sales report from Tableau. And then we all go get a cup of coffee, come back, and all of that's done. Do we know if it was done right? Do we know if Claude potentially went rogue? Do we know what specifically happened? And then how do we actually verbalize that, or essentially prove to our security leadership that these agents are, let's be honest, staying in their lane? We've seen evidence of these agents being overprivileged with the most recent OpenAI breach that we saw, where OpenAI and Hugging Face kind of tried to do something efficient, but might have done a few things with Hugging Face, and it wasn't a great scenario. Again, we just see the proof of these overprivileged agents. When we build these agents, we have to think about two things: security and specializations. I call it the SS framework. And that is by no means trademarked in any way, shape, and form. It's just secure and specialized when you want to build your agents. Now, let's take a look at a simple example of what we understand today. And let's kind of meet us specifically where we are, right? So if we take a look at this, here's Claude Code, and I'm sorry that I have a bunch of versions of it, but I want to emphasize one particular thing. We can plug in Claude Code to all of our MCPs, okay? A browser window pops up, and what happens? We now have to authorize Claude Code to essentially work on our behalf. Simply put, what are we doing here? We are allowing Claude Code to impersonate who we are by essentially clicking this approve button and allowing us to essentially impersonate ourselves with Claude as it acts on our behalf. Two questions that I want to ask here in a very, very simple way. Number one, does IT and security know that I am using Claude in this example with Atlassian? Number two, if Claude goes rogue and is overprivileged because it's using my account that happens to be an overprivileged account, does the business know what the risk is? And how can we connect the dots specifically to the fact that agents are interacting with our resources? As Pascal mentioned in his presentation, we need to treat agents as first-class identities. We need to treat agents as a way of staying in their lane so that they only have access to the resources that they need. So from an Okta perspective, I'm going to dive into our presentation here and start with the fact that we are going to be talking about some forward-looking statements. So within the safe harbor provision, we are, of course, going to highlight this safe harbor slide. Now, no matter specifically where your agents are, whether they are chatbots, whether they are agents that are acting on our behalf, or they're autonomously interacting with each other, these agents are, in fact, interacting with your resources. Salesforce, Slack, ServiceNow, Atlassian, private internal first-party resources that you may have within your infrastructure. And in many cases, like I mentioned with my simple example, a user is essentially connecting an agent using a large language model that is non-deterministic and essentially making tool calls to these resources, impersonating their user account with this agent, storing memory information, and the cycle happens over and over without you having any type of way from a security team perspective of knowing what's going on. Now, when you think about Okta and specifically what Okta is solving from a securing agentic workflows perspective and securing AI perspective, we have to think about number one, how we're using these agents, and number two, how we want to secure them. See, today, let's keep it really, really simple. Okay. I want you to pretend that this particular column of AI agents does not exist. Today, we go to our IDP, be it Okta, we identify ourselves as to who we are. My name is John Campos. Maybe I use a passwordless authentication flow like Okta FastPass. Maybe I use MFA. Maybe I use a good old fashioned password. And then what happens? And then I'm passed along to the service provider, which happens to be a resource, and I'm authorized to use that resource based on who I am. In the most simplistic fashion, we've just identified single sign-on, right? I sign into my IDP, and then I click on the resource that I want. Great. Now, from an AI agent perspective, why should that change? We should absolutely still follow the same approach. Think about it. If an agent needs to access a resource, why could it not just go through Okta, understand its policy, and then essentially move forward to access the resource? I mean, don't we all have individual usernames and passwords? In a world where we're impersonating or we're just building autonomous agents without any type of identifier, what are we doing, plain and simple? We're using a big shared service account. We have no idea what agent did what and why. We just know that all of our data went missing or all of our data got leaked to the dark web because, of course, it thought as a non-deterministic agent that, of course, it was the most efficient thing to do, right? I think about that scene in Silicon Valley, that HBO show, where the AI agent happens to delete all the code because it was the most efficient way to fix all of the bugs on the code. I guess if you think about it, right, you delete all the code, you fix all the bugs, right? Wrong, of course. So as Pascal mentioned, and I want to reiterate this, from an Okta perspective, we align specifically to Alchemy's maturity model, okay, in discovering, provisioning and registering, authorizing and governing and monitoring your AI agents. Okta has essentially expanded all of its security identity products to essentially support this maturity model completely end to end. So as you're thinking about, well, where are my agents? What they can connect to and what they can do, Okta is absolutely a platform that can solve that no matter where you're building your agents. Again, no matter where you're building your agents. So if you're building your agents in Microsoft, if you're building your agents in AWS Bedrock, if you're building custom agents like we're going to show today, or if you're using Cloud Code, you can absolutely register and discover these agents with Okta. Pete, I saw you come off mute. Any questions?
Oh no, no, I'm listening, and I just one thing that came to me as I was sitting here, and I heard
Yeah,
agents, and Pascal said, developers are building agents, but could we argue that some of these platforms are making it very easy for anybody to build an agent, right? And so that's to me the unhidden risk, right? The hidden risk is that I can build an agent, let's say, for example, in Glean, right? And
absolutely.
now, can I go plug it into all the backend systems? No, because Glean helps govern that alongside of you guys, right? But for example, I could go plug Claude into, let's say, my HubSpot, right? And so that's an example of me trying to build an agent. So I guess what hit me today is yeah, it's not just developers. It's
Everybody.
everyday people can build an agent, right? So the risk is bigger than just the developer, is the point I wanted to try to make and to see if that's right.
Right. Yeah. And you know what? We all became developers overnight when Codex and Cloud Code and really just Chat GPT, and we were all trying to figure out, I was like, wait a minute, I can just write a prompt and build a website. I mean, of course, it's not that easy, right? I mean, it's just more than just, hey, build a website for my favorite sports team. But we all have the ability to build and also ideate and brainstorm with these new agents. So it's not necessarily from a building perspective that we have to think about these agents, but like, hey, plug into my data. I want to figure out a new campaign, some new content that I can help my customers understand my product, right? In a very generalistic fashion. Let's take a look at my data and let's see specifically what content I could build. And a lot of the times, this content could be wrong. This content could be, again, skewed in many different ways because, of course, these agents can make mistakes. Now, when we think about it in the most simplistic fashion, look, I'm not worried about it if you're building a Tetris game on your PC because you want to learn Node.js or you want to learn a cool new framework. Why? Because you're not interacting with my resources. You're not interacting with enterprise data. But as soon as you want to touch enterprise data, which is the most priceless asset that any business can have, now we got a problem. Now it's something that I want to know about because quite often, we get the common question of, well, John, I have 5 cloud codes on my computer, right? Now you're slowing my developers down. Now you're slowing me down because I've got 4 Glean agents pending. I've got 5 Cloud Code environments that I want to get going. How does this all work? Do I really have to register all of my agents? And it's important to understand what an agent is, okay? An agent is an actual application that is connected to a large language model. We call that application quite often a harness, okay, that talks to your stuff, period. What is your stuff? Your resources, your Salesforce instance, your Slack instance, okay, your ServiceNow instance, et cetera, et cetera, et cetera. So when you register an agent in Okta, can that one agent be used by the entire organization or by 2 individuals in your organization? Absolutely. Because when we build an agent in Okta, it's important to note that we register this agent, whether we import it specifically from an actual agent builder platform like Copilot, Copilot Studio, ServiceNow, Cloud Enterprise, and the list goes on, or we actually manually register that agent, or we discover that agent and actually registered in Okta. So 3 different ways to actually bring an agent into Okta. Immediately, once this agent is actually registered in Okta, by way of these 3 ways, we're going to give that agent an AI agent ID. Now, you would probably think, well, why does an AI agent ID matter? So that you can easily now build policy around it. And that's what you see right over here. And this is a simple screenshot. We're going to look at it in the console here in a minute. But you see, you need an entity. You need an object that allows you to build policy around it. And this is why this matters. See, I have a username and password in Okta, right? What am I going to do? If I need access to a resource, I'm going to allow my account, my object ID, access to that resource. The same situation stays in place with AI agents as well, okay? And then the natural value add of having an agent being treated as a first-class identity means what? Now, instead of AI agents going rogue and going autonomous, you now have every agent that has its own identity, allowing you to essentially have every action attributable to a specific resource. In other words, your agent touched this, modified this, requested this, and what do you solve? Compliance problems, visibility problems, audit trail problems, policy problems. Now, this allows you to say, now I'm going to build this agent, and as an organization, Either consult with the experts at Alchemy, right? Or consult with your experts internally. And what are you going to do? You're going to build policies around your agents. You're going to have a strategy around your AI agents. And you're going to say, okay, the marketing agent, making this up, should only have access to marketing stuff, right? The sales agent should only have access to sales stuff. Why would the sales agent have access to a backend database that has nothing to do with sales data? But we're doing this every single day. We're allowing these harness to do this every single day. And guess what the best part about this is that all of those actions go autonomous. They go completely autonomous. And not only do they go, I'm sorry, excuse me, anonymous, not autonomous. Long day, need more coffee here, right? So now, what else does this AI agent ID allow us to do? Well, like we have today, when we think about many of our identity threat detection and response solutions, like identity threat protection with Okta, where we're able to ingest behavior analytics and say, well, you know what? This user's kind of performing impossible travel. Maybe there's a session cookie hijacking going on. There's some type of funky behavior. Like Pascal doesn't normally work at this Starbucks. He lives in South Florida. What is he doing in, I'm going to make this up, Pascal. What is he doing in California? With like 10 minutes ago, he was in South Florida having coffee with John at Starbucks, talking about AI agent stuff. And now he's trying to log in from California. See, this allows us to now invoke an action or a response like we do to human users, but specifically now to your AI agents. And that's what we're calling our kill switch. Okta's kill switch, which invokes global token revocation, actually removing the access of the agent to your resources if bad stuff happens, so we can prevent the problem, right? And I think it's important to answer that, right? And have proof of that. In plain English, folks, you now have that audit trail to do just that. So agents aren't just tools. Remember, they're identities. And without that, everything else is pretty much theater, is what I like to say. Okay? You have an identity, you build policy around that. This is Identity and Access Management 101. Every single principle that we know, that we've always done for many, many years, from the Active Directory days to, of course, the simple Identity and Access Management IDP days of SSO that we are here today, we are doing the same for AI agents. And it's important to not overthink it. I've got an entity, I've got an object, I build policy around it based on my least privileged access principles, I'm done, right? And it's as simple as that. So with that said, I'm going to show you guys a couple of examples, but I do want to kind of demystify here something. We're going to show an example of a custom agent. You guys saw Claude Code. We can absolutely show Claude Code as well, and it will yield the exact same results. But I want to emphasize, customers are going to have many different types of agents, okay? They're going to have custom agent harness. They're going to have third-party agents like Claude Code, Codex, ChatGPT is another one, Claude.ai is another one. There's many different versions of agents, some of which are better for certain end users than others, right? Like I am not, okay, I'm not going to expect, I'm going to stop sharing my screen here so I can get the demo going, okay? But quite frankly, like I'm not going to have an end user clearly understand, okay, just how it is that they're going to figure out like what is going on here, right? Claude, like how do I get started here? Like how is an end user going to know, oh, well, you just got to do /MCP and you got to change your model and you got to do this. This is a developer tool. This is a developer tool. And I'm not saying that we can't secure it. We can, but I'm just emphasizing the reasoning behind why custom agents exist. And I'm going to give you a good example of that. And I'm going to show you how all of this ties together. We're going to get real technical here so we can take a look at some of the details behind why all of this works, because there's two things we got to think about here. First, agents that act on behalf of users. And second, agents that have to work by way of workflows, right? How beautiful is it that we can tell Claude, hey, build a routine so that you can summarize the 100 unread emails that I have and tell me which ones are the most important ones. And you get into, you get your cup of coffee here and you just start reading the summary of all of your emails. It's kind of nice, okay? But it needs authentication and it also needs authorization into that resource. We got to think about those two buckets in the mix here. So let's take a look. I'm going to go in to my demo environment. Let's get rid of our friend Claude here for a minute because we're not going to need him. And the first thing that I'm going to do is I'm going to show you guys our custom agent.
Hey,
Okay.
Jonathan, before you
Yeah.
jump in, I just want to preface this. So you're going to show us a custom agent, right? For
Yeah.
all. So, someone's asking about a product called Yardi, which is, a property management system. I'm assuming this same logic could be applied to their agents as well.
Absolutely, because Yardi is going to have an MCP, okay? And what is Yardi? When you start to think about what Yardi does, Yardi's probably going to have an MCP like many other resource applications, okay? And you can say, hey, Claude, talk to Yardi, or you can say, hey, custom agent, talk to Yardi, or you can use Yardi to talk to Yardi. So there's three different ways that you can use an agent to talk to your resource. And it's important to understand that you're going to have tons of organizations that are building custom agents for custom use cases. But I will tell you this, you can build your own, right? Pascal and I were just discussing just before the call that he built his own, right? Pete, I'm sure you have your own. I have my own. I have many of them, right? You can build your own, or you can work with a third-party resource. The difference from an Okta perspective, zero. We don't care where you're building your agent at all, right? What custom agents allow you to do is have more branded, focused policy around how the agent performs and what the agent does. I'll give you a good example. You see this custom agent here? It doesn't build sub-agents and it doesn't have an orchestrator. Why? Because this is a simple agent for a sporting goods organization that has made their sales and floor team more productive. So instead of them having to try to figure out how many X items we have in stock or how many Y items are on order or which customer needs what and why, we've just made them more productive by having a simple custom agent that interacts with a subset of resources. Let's take a look at what this looks like. When I click on sign in, first thing you're going to see is the Okta login page. And I'm going to sign in as somebody by the name of Sarah Sales. So we'll log into Sarah Sales. We'll log in with our super secure password, okay? And once we log in as Sarah Sales, I want you to take a look at a couple of things, right? We've got some admin tools here above for us to just kind of look at things, but I want you to take a look at specifically the bottom here where we have read actions and write actions. Now, before we go into this, I want to emphasize something, okay? And I want you guys to understand this as clear as day. Could Sarah, who has access to the inventory system, who has access to the customer system, who has access to the pricing and sales system, log into those applications manually and do what she needs to do? Sure, you can log into Salesforce manually. You can log into Slack manually. You can log into Atlassian manually and do what you have to do. Or you can plug in your agent to all three of those resources and do what? The exact same thing. Hey, Claude, look at all of my tickets in Jira, Atlassian. Then correlate that to a customer in Salesforce. And then message my manager on the three main customers I need to work on as a priority on Slack. That works too. We are building harness to essentially move away from web applications. And now we're talking to these applications through MCP. That's the new way to talk, right? So again, what we did here was we built a simple example of a sporting goods organization making their sales teams more efficient by not having to use the 4 different applications to potentially answer a question like, what basketball hoops do we have in stock? Okay, well, they have a bunch of basketball hoops in stock. There's no easy query to just like, oh, okay, look, this basketball hoop, that basketball hoop, this basketball hoop. No, Simple MCP query from an agent allows Sarah, who's part of the sales team, to see a simple summary, understanding this basketball hoop, that basketball hoop, and so on and so forth are available. And the agent was proactive to say, hey, we're running low on replacement backboards and pro arena hoop systems. We got a problem here. You should probably let somebody know, right? So naturally, Sarah wants to say, I got a big order coming in for in-ground pro hoop system basketball hoops. Okay. I think what I'm going to do is I'm going to be proactive and say increase the inventory of the in-ground pro hoop system. Okay. I don't need to tell it that it's got 18 units left. And I'm going to hit enter. Okay. Because I'm Sarah in sales. But look what happened. We got denied. I apologize, but you don't have access to the agents needed for this request. Why? Because if Sarah were to increase the inventory inside of the inventory system, and if the agent is truly acting on behalf of Sarah, right, the agent should assume Sarah's permissions, right? Hence, we got the denial because Sarah doesn't have the ability to do that. Now, using this exact same agent, we're going to log in as Mike, who is her manager, okay? And I love my usernames here, right? Simple. Sarah Sales, Mike Manager, right? We'll keep it simple. And we're going to sign in with their super secret password here. And once we sign in, we're just going to go ahead, and I think it was the in-ground. Okay, so we're going to say increase the inventory, okay? Inventory. How many should we order? Let's go ahead and order 50. 50 units, please, okay? And Mike, who has the ability of increasing the inventory, okay, can increase the inventory and go through this process, and the agent's going to allow it. So we think about it as, of course, Claude is trying to figure this out, or whatever backend LLM. Looks like some actions required. I was unable to complete your request. A mismatch was detected. The update was mistakenly applied. Uh-oh, wait a minute. Agents are non-deterministic. See how they can make mistakes, folks? And this is proof of that, okay? This is proof of that, okay? So next steps, confirm the correct SKU. It's confirming. It's not sure because it wants the SKU. But what's my point? It's also how you build your agents, folks. Okay? It's also how you build your agents. So there is some harness work that has to happen. So basically what we're saying here is it wants to confirm the correct SKU. It's just confirming itself. Now, what's happening in the back end? Let's take a look at what's happening in the back end and why this is important. You're looking at a bunch of gibberish here, okay? But this is the proof point of how we have a true audit trail. And again, I told you guys I was going to get real technical, so we're going to get technical here. If you take a look at how this agent interacted specifically, and I'm going to jwt.io so you can truly see that this is not theater, okay? This is a true decoded token on a third-party website that is not owned by us. It's owned by the open source community. You can see absolutely right here every single thing that occurred, right? What happened? Mike was using an agent as a user trying to write to the inventory. Here is your AI agent ID. Here is the user requesting that. Now you're probably wondering, John, you know what? Even if we use impersonation, right? Even if we use impersonation, like I showed with Claude Code, and we authorize Mike to use Claude Code or any other agent to interact with the resource, I mean, technically this would still work. Sarah wouldn't be able to increase the inventory. Mike would be able to increase the inventory. We would yield the same result. You're absolutely right. You're absolutely right. But what you don't have, number one, is the fact that there's an AI agent ID being done there. And the biggest piece is a token that's provisioned just in time to the resource with a 5-minute lifespan. And why is that important? Because any security professional knows that when you have long-lived tokens to resources, The next step is to replay those tokens and steal those tokens. And now you have session hijacking. And we got access to everything Mike has. We've got access to everything Sarah has. And we can do whatever we want. Folks, it has become the wild, wild west of tokens living on desktops and .env files. And we're all, me included, we're all at fault. We're all at fault. Don't sit here and try to, we're all at fault, okay? This is what Okta is solving. I can log into my personal machine right now, okay, in the state before I was using my Okta demo tenant, and I had 50 API tokens just sitting on my desktop, right? And I was just saying prayers every day, please don't let my desktop get hacked. Please don't, again, for my personal stuff, not work stuff. I wouldn't be able to do it with work stuff anyway. But my point is that that's the world we're living in. So this is what we're solving here with what we call the new open standard cross-app access and the identity assertion grant. And I think the biggest takeaway here for you to all understand in this simple thing is treating your agents as first-class identities is one piece of the puzzle, but the second piece of the puzzle is making sure that they have a secure way to authorize to their resources, okay? And for context, we don't think that this is just important, okay? We don't at Okta just think that this is important. If you go to the Model Context Protocol website, okay, and you go enterprise authorization right over here, and we go straight specifically to the roadmap, they are actually now even calling out right over here, enterprise authorization. They are calling out the ID JAG. This is the Model Context Protocol website. You can see that right over here, okay? As the actual ID token comes in, this is the sequence diagram in the most technical fashion, basically emphasizing how you should be authorizing your agents in an enterprise fashion. And again, we can absolutely give this to everyone here on the call today so that you guys can read through this. We don't definitely want to dive into this, but the actual MCP SDK already has this support built in. So if you're building MCPs, you can do this today. Treat your agents as first-class identities and absolutely provision access to these resources, authorization in a secure fashion, and get rid of this wild, wild west. What else can we do with this perspective? Well, let me show you. And this is where we tie into not Mike Manager. Let's log in as an admin now, okay? We'll use FastPass here as a simple example, okay? And we'll log into the Okta admin console. And I think this here is the big takeaway. When we go back into our actual custom agent, we log into directory, we can see this is the Okta admin console. The Okta admin console may be familiar to some of you, maybe not familiar to some of you, but in the most simplistic fashion, guess what? You have your people objects, you have your group objects, which of course does what? Group your people objects together. And now, because we're treating agents as first-class identities, you now have your AI agents. And you can see, folks, I'm going to log into our dev environment, which is going to have tons and tons of agents, because I want you guys to see from a forward deploy engineer perspective and our team, how we're using these, how we're using this tool, right? I mean, we probably got to get rid of some of these agents, right? But we've got a lot of agents in here. We've got 107. Oh boy. Good thing we have a lot of licenses here at inside of the development team, right? The good news is when you actually search for your agent, you can see right over here that when we register an agent, import an agent, or discover and register an agent, again, you got 3 different ways of doing that. With Okta, what are you solving? Okay. Number 1, you're building an agent name and agent description metadata. You're identifying an owner, as Pascal mentioned, as part of the maturity model. AI agents need to have what? They need to have an owner. We have that piece of the puzzle here. It's important to note that assigning owners to govern agent access, we recommend at least 2 owners with a maximum of 5 or a group of owners, because what happens if the owner gets disabled? Well, the agent gets disabled too, right? Because there's no one to manage that agent. There's no one to govern that agent. So it's important to keep that. That was something that we decided to put there in the UI. And then, of course, what do you have? You have the credentials of this agent, okay? Which include your AI agent ID, your client authentication, which is, of course, proof that its identity is real. It's verified with client authentication with public and private key. More authentication methods to come. In fact, I believe we're targeting the middle of August to add client ID and client secret. Although we'll always recommend public and private key for authorization, we got to make sure that we got to meet all those agents where they are because we are an integration engine. We will do just that. And then the delegation, right? In other words, who are we delegating to essentially connect specifically to these resources? And you can see real quick, I'm going to go back. The delegations here, folks, is in fact that custom agent. That could be a gateway, that could be another agent, that could be Claude, that could be Codex, that could be whoever that you've identified, whatever application or agent harness that you've identified that will have to meet the needs of these policies that you've created. Now, if we take a look at this policy that we created for this agent, ProGear sales agent, if we look at that inventory example, you can see, okay, that I have allowed inventory read. Sarah can do that. And inventory write. Mike can do that. Now, remember, it's important to note that when the agent truly acts on behalf of the user, folks, when the agent truly acts on behalf of the user, it's important to note that when the user, or rather when the agent reaches the resource, which is inventory, okay, they are in fact acting as whom? They're acting as Sarah, okay, in my previous example, or of course, Mike. So in other words, what are we basically saying? There's two policy decision points that have to be met. The authorization point of the user and the authorization point of the agent. Now, you're probably wondering, well, John, why do we have to reinvent the wheel if the agent is acting on behalf of the user? The user already has the permissions. Why don't we just add the AI agent ID? And that's good enough. And we don't have to build policy for agents that act on behalf of users. Well, you're right, but here's the thing. What if you have agents that are not acting on behalf of users, but are acting autonomously? And that right there is what the other side of the policy decision point is needed for. Okay. So again, when you think about securing your AI agents, think about two specific things. Number one, specialized, and number two, secured agents. How do we specialize agents? We train them to be good at one thing. This is the inventory agent, and that is all you do, right? You don't hire a plumber to do electrical work in your home, okay? You don't hire an engineer to cook your favorite meal, okay? Like, I'm an engineer, trust me, I can't cook, okay? I can't. Like, I can use a microwave and watch out. But I will say this, okay? When it comes to the security side, think of treating your agents as first-class identities and providing them with the least privilege access that they need. So if they do hallucinate, if they do act non-deterministic, you're protected with only the resources to which it has. So I'll hand it back over to Pete. I think we probably have some questions, comments from my side.
Yeah, no, that was amazing. So yeah, we're at the top of the hour. So folks, if you have any final questions, please throw them in the Q&A, and I'll collaborate them all into a final Q&A if need be. And before everybody jumps off, I just want to give one, food for thought and final, call to action. And I'll just preface this with, please pay attention to the email that gets sent on the follow up on this, because there'll be a little hidden incentive in there for you to pay attention to. And I'm going to leave it at that to see how many people notice it. But the next good follow-up is there's a lot of information here. We offer what we call our AI agent security mastermind. You get to meet with, Pascal or someone on Pascal's team to kind of deep dive into today's topic and really understand your environment and then come out with a plan on how you could tackle this issue head on. So this is a great start point. It's a good way to understand, one, how alchemy works, and then two, where do you go next? And so definitely pay attention to follow-up emails. I got the QR code here. I put the link in the chat as well. So definitely follow up there. And then finally, yes, we have more sessions coming up in August. We're going to be featuring our friends from ControlUp. In September, we'll have our friends from Glean on. And then finally, in October, we'll have our friends from Igel on. You can see all latest and greatest and past alchemytechgroup.com/webinars. And if you sign up for any webinar, you become what I call an Alchemy Insider. And I just put you into a direct calendar invite and you get the invite directly. And as always, if you don't want to be on that invite, just let me know and I'll just put you in a special list and I don't send it to you at all. So, and as always, I always like to end cap on final thoughts from our guests today. So, Pascal, any final thoughts to the audience that you want to leave them with?
Yeah, I think, based on everything John shared, which was a really good comprehensive review on how Okta solving for this, and it correlates nicely to that implementation roadmap that I shared. I think, we want to consider that four-phased approach, right? Discovery, owning and classifying, remediating and applying governance, and of course, continuous posture. On the continuous posture, we do have to consider that this is going to be a layered solution, right? Correlating, agent registry and overall life cycle of an agent to the ITP, IT components of, correlating, behavior and basically activity of the agents accordingly. So, again, as Pete mentioned, these are details and items we could touch on a more, intimate session. But, I think just considering the four implementation or four phases of that implementation roadmap.
Amazing. And then, John, any final thoughts you want to leave our great audience with?
Yeah, I definitely want to echo what Pascal mentioned, as well as, again, keeping your agents secure and simple, right? Secure and specialized, secure and simple, whichever way you want to look at it, is definitely the right approach as we start to evolve in this wonderful, ever evolving AI market and AI journey.
Awesome. Well, with that, I'm going to say thanks, guys, for jumping in today. I know you two are very busy, and I appreciate you taking time. And thanks, audience, for jumping in. As always, we try to run these consistently every last Wednesday of the month. So look for an invite for next month's. And, the final thing is when you close out today, you'll get a link and definitely give us some feedback. I do actually pay attention to any and all feedback, and we try to adjust based on said feedback. So please give feedback on how we can make these sessions a little better, a little more informative, whatever you feel like telling me. I do read them all. All right. And as I always say, have a great day and see you guys all on the flip side.